So assignment number 10 in Unit 7 is about the fundamental theorem of algebra. Just what is the fundamental theorem of algebra? Let's talk about that first. It's very, very simple and you already know it. Polynomial of an nth degree has n solutions. So if we have a second degree polynomial, it's got 2 solutions. If it's a third degree polynomial, if it's a cubic polynomial, it's got 3 solutions. Now they might be real, they might be imaginary, they might be rational, they might be irrational, but there are 3 solutions. There might be one that shows up twice that has a multiplicity of 2, but there are still 3 solutions. If it's a 7th degree polynomial, it's got 7 solutions. How does this help us with anything? Well, let's just take a look at all the possible solutions. Whenever we have a solution, it's going to be a type of a complex solution. That's a complex number. And so every solution is going to be complex. So if it's a 6th degree polynomial, we've got 6 complex solutions. Well, those solutions are either going to be real solutions or they're going to be imaginary solutions. Okay, and so if I have 6 total solutions, all 6 could be real and no imaginary. It could be 5 real, 1 imaginary, 4 real, 2 imaginary, and so on. But they're either going to fit into this circle here or this circle here. Well, if they're real solutions, they're either rational or they're irrational. And so it could be like the solution is 3, but the solution could be the square root of 3. And if it's the square root of 3, it would be irrational. If the solution is 3, then it's rational. If it's 2/3, it's rational. If it's the square root of 5, then it's irrational. But one thing from yesterday that we should know now is that if they're irrational or if they're imaginary, they're always going to come in pairs. Here's why. If there's an imaginary solution of I, if I is a solution, well, so is negative I. If 4 plus 3i is a solution, well, so is 4 minus 3i, because those are the conjugates. And if one is a solution, the other one automatically is a solution. If the square root of 3 is a solution, well, so is negative square root of 3. If 2 plus the square root of 3 is a solution, so is 2 minus the square root of 3. So those will always come in pairs. How does that help us? Well, let's take a solution like this. This is our first 5th degree polynomial that we've really looked at. We're not really going to solve it, but we're going to be able to answer some questions about it. For example, the first question, how many complex solutions are there? Well, it's a 5th degree polynomial, so there are 5 complex solutions. Well, of those complex solutions, how many possible imaginary solutions could there be? Well, we know imaginary solutions come in pairs. We can't have one imaginary solution because if we have one, we're automatically going to have 2. We can't have 3 imaginary solutions because if we have 3, we're automatically going to have at least 4. Could be 6. But they always come in pairs. So the imaginary solutions are either going to be 2 or 4. We can't have 6 because we've only got 5 solutions. Well, then how many possible real solutions are there? Well, remember, every complex solution is either imaginary or it's real. And so if there are 2 or 4 imaginary solutions, let's say there are 2. We have 5 total solutions. If 2 of them are imaginary, that would mean 3 have to be real. If 4 of them are imaginary, 1 could be real. And if we have 0 imaginary solutions, which I guess is also a possibility, that would mean all 5 of them are real solutions. So how many possible real solutions are there? Could be 5, could be 3, or there could be 1 for this particular equation. So what are the possible rational solutions? Well, here we get into some specifics. Possible rational solutions, remember that the rational solutions, we're going to have the factors of 72 on top. So that could be 1, it could be 2, plus and minus all of these. I think 3 goes into 72. I think 6 does. I think 9 does. I think 12 does. I'm sure there's some that I don't know about here. There's 36 that does. There's 72 that does. I have to think more about all the factors. 27 I think does. And so I would list all the factors of 72 on top, and then all the factors of 1 on the bottom, which is just 1. And so I could list all of these separately. Those are the possible rational solutions. that we could start to plug in and use synthetic division for to figure out which one is actually a solution. But we know that there are 5 of them, and we know a little bit about those solutions before we even begin to solve this problem. That's what we're working on today. Let's take a look at one more question here. It says solve it. That means find all the solutions. Well, now what we want to do is actually take all of our possibilities here and see which one of those actually works. So to solve this, I'm going to start with synthetic division, and I'm just going to use this. I'm going to use this up here as 1, and then -2, 13, -26, 32, and 72, just to save space. I'm going to put my line right here, and in this box out on the outside, I want to try one of these numbers. Well, after using my calculator, I know one of them that I think works is going to be 2. Let's just try this out. I'm going to take 1 down here and multiply it times 2, which gives me 2. I'm going to add -2 plus 2, which is 0, multiply it times 2, which is 0. I'm going to take 13 plus 0, which is 13, multiply it times 2, which is 26. Take -26 plus 26, which is 0, multiply it times 2, which is 0. 36 plus 0 is 36, multiply it times 2, which is 72, and I do get a remainder of 0. And so one factor then is x minus 2. And so I know that one solution is 2. I know then that my other factor is going to be, this is my constant term, linear, quadratic, cubic, quartic. It's going to be x to the 4th plus 13x squared plus 36. And when that is equal to 0, I would get 4 solutions. So I could try to find the factors of 36 over the factors of 1, but maybe this is going to be one that I can factor here. If I have x squared here and x squared here, I want something that multiplies together to give me 36 that adds up to 13, like maybe 9 and 4. 9 times 4 is 36. 9x squared plus 4x squared does give me 13x squared. And so that means two of my solutions are going to be when x squared plus 9 equals 0. The other two are going to be when x squared plus 4 is equal to 0. And so if I subtract 9 from both sides here, I'll have x squared equals -9. Take the square root of both sides, and x is plus or minus 3i. There's 2 solutions. And then if I do the same thing here, I'll have x squared equals -4. Take the square root of both sides, and x is going to equal plus or minus 2i. And so in this particular case, I did have 1 real solution. I had 4 imaginary solutions, 5 altogether, and my solutions are 2 plus or minus 3i and plus or minus 2i. Let's take a look at a different example. We're not going to solve these necessarily, at least at the beginning. What I want to do is just answer some questions about them. And so here's the first set of questions for I'm going to call this number 2 here. How many complex solutions are there? Well, it's an 8th degree polynomial, so there are 8 complex solutions. How many possible imaginary solutions are there? Well, they always come in pairs. So all 8 could be imaginary, but if I start with the lowest set, it could be 2, could be 4, could be 6, could be 8, or I guess it could be 0 as well. How many possible real solutions are there? Well, if none of them are imaginary, that means all 8 will be real. If 2 of them are imaginary, 6 will be real. If 4 of them are imaginary, 4 will be real, and it could be 2 or it could be 0. What are the possible rational solutions? Well, I'm just going to write it like this. It's going to be plus or minus 1 or plus or minus 3 over plus or minus 2. So I could say it's positive 1/2, negative 1/2, positive 3/2, or negative 3/2. So the same thing with number 3 over here. We're going to answer similar questions. How many complex solutions are there? Well, it's a 7th degree polynomial, so there are 7 complex solutions. How many of those complex solutions are imaginary? Well, it's either going to be 2, 4, or 6, because they come in pairs. How many of those possible are real solutions? Well, if none of them, I guess it could be 0 also, I always forget that one. If none of them are imaginary, that means all 7 would be real. If 2 of them are imaginary, it could be 5 real ones, or 3 real ones, or 1 real solution. And then what are the possible rational solutions? Well, the possible rational solutions are going to be the factors of 5, which is plus or minus 1 and plus or minus 5, over the factors of 3, which is plus or minus 1 and plus or minus 3. All the combinations that I can make out of that, but we can leave it like that, and I would be fine with that. That's what this assignment is about. That's what your homework is about, and we will see you tomorrow in class.